All right, what we have is we're going to go through some problems on differentiation, all right, using trig functions and differentiation and using the chain rule. Okay, so first off, what we have is, this is actually a worksheet that I have, and we're going to go through some odd problems. I have k of x equals sine of x squared plus 2. Okay, we're going to find the derivative of this. Excuse me. To find the derivative, what we're going to do is we're going to take, and we have to use a chain rule. What we have is an outside function. This is sine of x squared plus 2. So we're going to first take the derivative of the outside function, which would be sine. It's going to give us cosine of u. Now u is the inside function, x squared plus 2. We're then going to multiply that by the inside function, which would be our u, which would be 2x. And that would be our derivative. And that is for problem number 5. Problem number 7, what we have is h of x equals cosine the 5th power of 3x. Now, whenever I have a problem like this, we like to rewrite this as cosine of 3x, all of that to the 5th power, because that means this little expression means we're taking the entire quantity cosine of 3x to the 5th. To find this derivative, we're going to take the derivative of the outside function. Now, our outside function is u to the 5th, u to the 5th. So when you have u to the 5th, that's our outside function. And our inside function, u, is going to be cosine of 3x. So take the derivative of our outside first. So it'd be 5u to the 4th. Now our u is cosine of 3x. Now we're going to take that, using a chain rule, the derivative of u. Now the derivative of u, notice we have another composite. So we're going to take the derivative of this outside, which is cosine, so it'll be negative sine of 3x, times the derivative of the inside of that, which is 3. Okay, we can simplify this to 15, negative 15 cosine of 3x to the 4th, sine of 3x. And that would be our answer. All right. Now, moving on, we can look at number 11. Now, number 11, we have h of s equals cotangent of s cubed minus 2s. Once again, we're going to use a chain rule. We have h prime of s. Our outside function, again, is cotangent. So the derivative of cotangent is negative cosecant squared of the inside of our inside function, which is u, is s cubed minus 2s. Finish this off by taking the derivative of u, the inside, which would be 3s squared minus 2. And that's our derivative. Number 17, we have another derivative we're going to find of k of z, which is z squared cotangent of 5z. Now, the derivative of k, we have z squared cotangent of 5z. So to find this derivative, we're going to use the product rule. All right, the product rule. Okay, so we're going to take the derivative first, which is 2z, times cotangent of 5z. Plus now the derivative of cotangent. Cotangent of 5z, well, outside function is going to be negative cosecant squared of 5z, times the derivative of the inside, which is 5. And then we're going to finish the product rule. We're going to finish the product rule by multiplying by z squared. All right. With that, if we want to simplify it, we can write 2z cotangent of 5z minus, I'll put z squared in front, cosecant squared of 5z. Oops, put that 5 also right here. Put that 5 right there. Of 5z, and that's our expression. All right. Hopefully this is helping and you're understanding a little better. Okay. We'll go to another one. We have number 23. All right. 23, we have f of x equals cosine of 4x over 1 minus sine of 4x. Now, notice how we're doing a lot of these cosine of 4x, sine of 4x, tangent of 3, 5x's, and whatnot. When you find these derivatives, these are very, very common. You have to be very efficient in doing this. So here we have cosine of 4x over 1 minus. So we're going to use the quotient rule. First off. So take the derivative of the numerator. All right? Derivative of cosine is, when you use the chain rule, negative sine of 4x times the derivative of the inside, which is going to be multiplied by 4. All right? Times the bottom, or the denominator, minus now the derivative of the denominator. Derivative of the denominator right here is going to give us negative cosine of 4x, because that's 0, 1, 0. This is going to be negative cosine of 4x times the derivative of the inside, which is 4. Times the top, all over the bottom squared. 1 minus sine 4x, the quantity squared. Excuse me. We could simplify this a little bit. We have negative sine, I'll put a 4 right there, 4x times 1 minus sine of 4x. Negative, negative makes a positive. We have cosine of 4x times cosine of 4x. We have this 4 right here, put the 4 right there. We get cosine squared of 4x all over the quantity 1 minus sine of 4x, the quantity squared. Okay? Now we have one more on the sheets that we're going to talk about. And I'll pause it. All right. We have one more, 25, where we have t of x, which is tangent of 2x minus secant of 2, secant of 2x to the third. All right, we're going to find this derivative. So to do this, we're going to take the derivative of t prime, so it's going to be 3. Our outside function, all right, is u to the third. U is going to be tangent of 2x minus secant of 2x. And we have this, the derivative of u, which is 3 tangent of 2x minus secant of 2x squared, times the derivative of the inside now, the tangent of u. Now, when we take the tangent of u, the derivative of tangent of 2x is going to be, well, we have to make sure we take the derivative. This is not tangent times tangent of 2x. So we take the derivative of tangent, which is secant squared of 2x, times now the derivative of the inside, so it'll be 2. Minus now the derivative of secant. Now the derivative of secant of 2x is, well, we know what derivative of secant is. Secant tangent. Now this is where sometimes students get a little screwed up. Oh, sorry. I'm in a room over here. Just move this down a little bit, a little bit, oops, a little bit, a little bit, a little bit, and a little bit. Okay. All right, and we're going to multiply this by 2. The inside, we have to keep the 2x. A lot of students forget that, or they just write secant tan, and they don't put any value, any input in. Secant is nothing without its input, which is, in this case, 2x. Tangent is nothing without its input, 2x. Secant tangent is the derivative of secant, and then we have to multiply by the derivative of the inside, and that's where we get to 2. And then we can close the parentheses, which you see right there, and that is our derivative. Nice, long, and tedious. Okay? We could factor out some things if we wanted to, but that is what we have for our answer. So, these are some chain rule problems with trig. I hope this serves you well and helps you understand this a little bit better. I will have other tutorials and other examples on doing some other additional problems with this. All right, good luck and God bless.